everything we do is available eventually on BioniChaos.com, so go check it out, provide your feedback. At the synthetic EEG signal generator, let's go EEG, and ideally we have an animate button for this. Okay, so Perplexity, Gemini, or ChatGPT, which one should we use for voice?
Synthetic biomedical data, such as EEG signals, are artificially generated patterns that mimic real biological data to facilitate research and development while preserving privacy and enabling algorithm training. Synthetic data is artificially generated to closely resemble real data, maintaining statistical properties and structure, whereas fake data is inaccurate or misleading information that does not reliably represent real-world data characteristics. Exactly. If you generate synthetic data from a dataset with issues, the problems can be reflected and even amplified in the synthetic data. It's crucial to first clean and pre-process the original data, ensuring it's accurate and representative before generating synthetic data for training to avoid perpetuating those issues. Generating synthetic data based on theoretical models can be beneficial as it allows you to define data characteristics and control for specific variables. However, it may not capture the complexities and variability found in real-world data. Combining theoretical models with real data helps to ensure that the synthetic data is both realistic and useful for training models.
Yeah, everything we do is eventually ends up on BioniChaos.com, so go check out the tools. This one, for example, EEG Signal Simulation. It's generating synthetic data, not to be confused with fake data, as discussed with Perplexity before. Okay, so it's a single HTML, which is great. This is awesome. Can we also mention the difference between synthetic data and fake data, and also describe if the waveforms in these web applications are generated based on another dataset or just the theory behind EEG? Doing a synthetic podcast as well as synthetic data generation. Also, while the podcast is being generated, we could also add an option for automating for a demo mode. Can you just explain real quick, how do we add a demo mode that will essentially showcase what this web application can do? So essentially we'll move the controllers one by one continuously to showcase how the web application works.
I've added a demo mode that adds a Start Demo button next to the presets dropdown. When clicked, it cycles through a sequence that demonstrates different brain state presets: deep sleep, light sleep, relaxed, focused, EMG artifact effects by gradually increasing and decreasing muscle artifact, EOG artifact effects by gradually increasing and decreasing eye blink artifact.
Are we moving one controller at a time, or are we changing different controllers at the same time?
We could slow it down to focus on one control at a time.
We have everything in a single HTML, so we could potentially give it to someone else. Again, while it does it, let's just do the overview of what is it we're trying to do and why. So we'll have some professional podcasters doing it for us.
So, Evie, you dragged me all the way to the Brainwave bistro to talk about brainwaves? I thought we were getting molecular gastronomy. This better be good.
It is good, Sid. It's scientifically good. See that website I sent you? The Advanced EEG Signal Simulator? That's what we're diving into. Think of it as a DJ mixer, but for your brain's electrical signals.
A DJ mixer from my brain. So I can finally drop the sickest delta wave beats for my morning commute? My sleep apnea is gonna rock?
Exactly. Or more accurately, you can simulate dropping those beats. This isn't actually hooking up to your brain, thankfully. It's a tool for exploring what EEG signals look like.
Okay, so I'm looking at these charts, and it's all squiggly lines and colorful blobs. Explain it to me like I'm a particularly dense, albeit charming, neuron.
All right, dense but charming neuron. On the right, you've got two main graphs. The top one, the power spectrum, is like a musical equalizer for your brain. It shows you how much oomph, power, different frequencies of brain activity have. Are you chilling with slow, deep delta waves or buzzing with fast, alert beta waves? This graph tells you.
So if my beta waves are off the charts, I'm basically a human espresso machine. Got it. And the bottom graph? More squiggles.
That's the simulated EEG waveform, or the time domain. Imagine listening to the full song produced by your brain's orchestra. It's the raw, jumbled voltage fluctuations over time. The actual EEG signal you'd record from a person's scalp looks a lot like that.
So the top one is like looking at the sheet music, and the bottom one is actually hearing the symphony. But it's a symphony played by like a million tiny, slightly drunk conductors, right?
Excellent. And that's where the simulator's magic comes in. On the left, you have your conductor controls. You can adjust the tempo, frequency, the volume, amplitude, and even how messy each section of the orchestra is, bandwidth, for delta, theta, alpha, and beta waves.
Wait, delta, theta, alpha, beta? Those are the brainwave bands, right? I vaguely remember them from that one documentary where they hooked a guy up to electrodes and he started levitating. Or maybe that was a fever dream.
Probably a fever dream, but yes, those are the main ones. Delta, super slow, deep sleep. Theta, drowsy, light sleep, deep meditation. Alpha, relaxed, calm, meditative, eyes closed. Beta, awake, alert, focused, active thinking. There are gamma waves too, but this simulator focuses on these four for clarity.
So I can crank up the deep sleep preset and see a massive delta spike on the equalizer, and then I can watch the raw signal on the bottom turn into a slow, lazy river.
Precisely. And then the fun part, artifact simulation.
Artifacts? Like ancient Egyptian brainwaves? Is my brain secretly storing the blueprint for the pyramids? Or maybe that was a fever dream.
Not that kind of artifact, Sid. In real EEG recordings, you often pick up electrical noise that isn't from the brain. Things like muscle movements, EMG, or eye blinks, EOG. This simulator lets you dial those in. Try adding a lot of EMG. You'll see a lot of fast, chaotic noise on the signal and a broad hump across higher frequencies on the spectrum.
So I can make my simulated brain signal look like it's having a seizure while also trying to read a very blurry menu. Fascinating. But Evie, here's a crucial question from a professional purveyor of fabrication. Is this fake data? Like, is this the scientific equivalent of CGI for brains?
That's an excellent question, Sid. And that brings us to a key distinction. This is synthetic data, not fake data.
Aha! What's the difference? Synthetic sounds like fancy fake, like artisanal plastic.
Not at all. Fake data often implies data that's been fabricated to deceive or to support a predetermined, often incorrect conclusion. It's actively misleading.
So, like a politician's opinion poll.
You could say that. Synthetic data, on the other hand, is deliberately generated based on known principles, rules, or mathematical models to mimic the characteristics of real data. It's transparently artificial, but designed to be representative.
So, this isn't trying to trick anyone into thinking it's a real brain scan. It's more like a highly detailed interactive diagram.
Exactly. We know the mathematical properties of sine waves, which are the building blocks of these brain waves. We know the general frequency ranges and amplitudes for delta, theta, alpha, and beta. This simulator combines these theoretical components. It then adds noise, artifacts based on how those artifacts are known to manifest in real EEG. It's all grounded in the underlying theory of EEG signal generation and characteristics.
Got it. So it's like a meticulously crafted model train set, not a hastily photoshopped picture of a train. It looks like a train, it acts like a train, but you know it's not going to take you to Schenectady.
Perfect analogy. And to answer your other question, no, the waveforms here aren't generated based on a specific, previously recorded dataset. Instead, they are built from the ground up using fundamental signal processing principles. Each brainwave is essentially modeled as a series of slightly randomized sine waves within a specific frequency band. That's why we have bandwidth controls, not just a single frequency.
So the simulator isn't just replaying a recording of someone else's brain. It's essentially building a brand new theoretical brain activity moment by moment based on my settings. That's oddly profound.
It is. This makes it incredibly valuable for learning and research. If you're developing an algorithm to detect alpha waves, you can use the simulator to generate a signal with a known alpha wave presence and test your algorithm's effectiveness. You have the ground truth because you built the signal yourself. In real EEG, finding that ground truth is often a huge challenge.
So I can make a perfectly alpha wave dominated brain, run my hypothetical meditation app algorithm on it, and see if it correctly identifies the chill vibes. If it works here, it might work on a real human who's probably just thinking about their grocery list.
Precisely. It gives you a clean, controlled environment to understand complex phenomena before diving into the messy, unpredictable world of real human brains. It helps build intuition. The A Deeper Look section even explains why the actual signal spectrum might look different from the ideal overlays due to constructive and destructive interference, a fundamental signal processing concept.
Yes, the podcast section. I appreciate that you've got an audio explanation for us auditory learners, or for people who are just too lazy to read, which, coincidentally, describes most of my audience. So, to sum up, this web app is a teaching tool, a testing ground for brain tech nerds, and it helps you understand why your sleep app keeps telling you you're restless when you just blinked really hard.
That's a perfect summary, Sid. It empowers people to demystify EEG data and explore the intricate world of brainwaves in a hands-on way. And who knows, maybe it'll inspire someone to develop the next breakthrough BCI.
Or at least a really good brainwave DJ set. Thanks, Evie. Now, about that croissant, can it simulate a full night's sleep for me? Because I've got a gig tonight and my delta waves are doing the Macarena.
We're working on that, Sid. One synthetic brainwave at a time.
Yeah, it was a notebook LM equivalent. And there is a human in the loop. If you have any questions, go for it. Go for the chat. Okay, so we're actually trying to do two things at the same time. That's probably why we didn't succeed in everything we do. Eventually goes on to BioniChaos.com. Go check it out. Provide your feedback. Have a list of featured tools: cochlear simulation, ECG simulation, cochlear insertion, cochlear implant, electrode array insertion, rhythm scan. We're actually training models quite successfully, so they're performing pretty well. All the results are there. The Python code is on the page as well. This is on EEG data and not synthetic. So, and that's the thing with synthetic data. That's what Perplexity didn't mention before, is that if we add synthetic data to the mix, we could actually enhance the data set, make the training more accurate. So for example, we could actually see where the training is failing and generate more examples of that sort. So during training, the model knows better. Now the question is if, so those are seizures. Currently in the simulator, we don't have an option add seizures. So this is something we are looking into. Yeah, I'm not sure if it's better. It's probably not. So I'm having trouble fitting the whole thing into the screen. The only solution would be start adding tabs, which I'm not a big fan of. I do not like tabs. So the demo mode is nice. Also though, in addition to the demo mode, can we add the functionality that when the user is not interacting with the page for more than 5-10 seconds or so, let's say 10 seconds, the demo mode will start automatically, and if the user interacts with the page again, the demo will stop. What are you talking about? No. First of all, no. Second, we're talking about the entire page layout, not the individual graphs. We're talking about everything together. So we're trying to avoid adding tabs for the two graphs. So essentially we want all the controls and the two graphs appear in one viewport. Everything we do eventually available on BioniChaos.com. Go check out the website. Let us know what you think. And we have the two versions. So we'll just, the way we develop is that, yeah, it's like vibe coding. We're not looking at the code, but then we'll have two versions. We'll compare between them, like actual testing, whatever is needed to test it properly, and then we'll choose one. So we'll have two versions of this code. We will test the new one. Okay. So which one's better? Well, obviously this one's better because it's working. The second one, I'm having trouble with the graphs. Where's the advanced thing though? Yeah, we did have the single tab for the customize button. Yes, we'd like the layout. Can we just make the two charts fit the screen? That's pretty much it. Okay, all we need is to get the prompt right and make sure the demo is working correctly. Making sure the demo is working correctly. I think it is. That the demo mode is becoming faster over time. I don't know why is that happening. We'll try fixing it next time.